Introduction to Hadoop, or you can say welcome to big data. So we'll be starting this session with a agenda. Agenda is internet in real time. What is Hadoop? Master slave architecture. Hadoop distributed file system, which is also known as HDFS. MapReduce. Hadoop services. What is big data? Why Hadoop is important for career. Prerequisites to learn Hadoop, and Hadoop training details. So this is the agenda, and we'll be covering them one by one. Starting from first one, internet in real time. Needless to say that every single device is connected to internet nowadays. Whether it's your PC, it's your laptop, it's your smartphone, your tablet, or anything. And different activity which we do from morning till evening, that is ultimately increasing the data over internet. You are using WhatsApp, you are doing Facebook, you are using online banking, you are purchasing products from eBay, Amazon, Flipkart. Everything, whatever you do over internet, that is increasing the data 24/7 across the globe. This is a screenshot of a website which can give you the real-time idea how much of data is being generated. The link is given at the bottom of this slide. I can even click on that link, but it will these stats will keep on changing, and it would be difficult for us to discuss about that. That's why I have just taken a screenshot of that, and maybe once I will share this PDF with all of you, you may be interested to click on the link and you want to see how these things are going on. But right now, we can talk about this screenshot. You can see at the bottom of this screenshot, it is saying that, by the way, in the 5 seconds you have been on this page, approximately 1,12,870 GB of data was transferred over the internet. Did you notice one thing? These stats are only for 5 seconds. And in these 5 seconds, 55 accounts are created and 28,500 tweets are there. If I talk about YouTube, 11,570 video hours are uploaded, or you can say watched, and 10 video hours are uploaded. Similarly, we have details for different other big data generator. You can talk about LinkedIn, 9110 user searches. Skype, 1,15,740 minutes are used on Skype. Google, this many searches and this much of revenue generated. Amazon, these many items purchased, this much of revenue generated. These many applications downloaded from App Store, from Play Store. We have different, you can say, millions of likes and posts. 30 GB of data was transferred only on Facebook in just 5 seconds. So you can imagine the data size. If this much of data is being generated, being transferred over internet in just 5 seconds, and if I will talk about data of 1 day or 1 year or maybe last 10 years, then what would be the data size? So to deal with this much of data, we need a technology that is Hadoop. Okay, so moving to the next slide, what is Hadoop? Hadoop is an Apache product. Apache is the company which is developing this Hadoop. The next is an open source framework. I would request everyone to keep yourself on mute in case you are not speaking. Sai, can you please mute yourself because there is a little disturbance from your end.
Okay.
Okay, thank you. So friends, I would again request, in case you are not speaking, please keep yourself on mute. In case you have something, you are most welcome to mute yourself and you can talk to me. Okay, so this is an Apache product and this is an open source framework. Open source, as many of you are not working in IT industry, let me tell you, open source means this is free of cost available. You don't need to pay anything. You don't need to purchase any license for that. So this is Apache product, so you can directly go to Apache website, download Hadoop from there and use it. Very simple. Another aspect of Hadoop is this is distributed storage and distributed processing. it seems like there are few technical terminology, distributed storage, distributed processing. We all are technical guys. We can anytime explore this technical stuff. I think we should start with some layman example. We must be very much clear on the basic concept of Hadoop, and then we can go deeper and deeper. Let's take a layman example. Suppose there is a school. In that school there is a principal and there are 10 teachers. Now there is a task of checking 1000 answer sheet of the students. Now principal may be qualified enough to check all those 1000 answer sheets. But here the challenge is, if a single person will try to check 1000 answer sheets, it will be taking a lot of time, right? Instead of that, we have another option. Principal can distribute the same task among 10 teachers. And I think 10 teachers will be definitely taking lesser time to complete the job. I think this is very old mathematical formula. You can say more number of workers will be taking lesser time to complete the job, and less number of workers will be taking more time to complete the job. The same funda applies to Hadoop. In Hadoop, we are not concentrating on a single system for storing the data and even for processing the data. That means your data is distributively stored on multiple machines, and data is processed by multiple machines. And when we say multiple machines, there is no limit. If I talk about Yahoo, they have set up a Hadoop cluster of 4000 machines. What they are doing? They are analyzing the Yahoo mails. Millions of emails are coming every day, and out of those mails they are finding out which one are the genuine mails and which one are the non-genuine, or you can say spam mails. Ultimately they are doing some type of analytics on some data. So again, coming to the school example, just like your principal was assigning some task to the teachers, similarly Hadoop is also having a similar architecture. So we'll be talking about that in the next slide. So using the distributed storage and distributed processing, you can deal with large amount of data, because now you are not bound to the hard disk of a single system. You have multiple systems, you can have any number of systems, and you can have ultimately very large amount of distributed storage, and definitely you can deal with large amount of data then. So moving to the next slide, master-slave architecture. In the school example, principal was controlling the teachers. Principal was assigning the task distributing the task among multiple 10 teachers. Same fund applies to Hadoop. We have a master and we have multiple slaves. You can see in this picture. We have a master machine and we have multiple slave machines. And along with this, we have a secondary master as well. Just like in schools, there is a vice principal, right? In case principal is absent, there must be someone who can take care of the activities. The same fund applies to Hadoop. In case master is down, then who will be distributing the task among slaves? We need a backup of master. That is known as secondary master. And one more thing you can notice is we have the user who is interacting with master. The user is not interacting with slave machines directly. So you can say that as a user, we can simply request the master that this is my large amount of data and I want to store it on multiple machines, and master machine will do that for me. Similarly, if I want to process the data, again I would request the master machine that this is my large amount of data and I want to process it. It's master machine duty to distribute it among multiple machines, and accordingly it can process. So this is your master slave architecture, and this group of machine, master, secondary master and all slaves, this complete you can say group of system is known as Hadoop cluster. Moving to the next slide.
Okay.
Friends, we talked about two things. One was distributed storage. That means we are not concentrating on a single machine for storage. Instead, we can split our bigger files and we can store those smaller parts on multiple machines. So the part of Hadoop which is dealing with the distributed storage is, you can say, so that is known as Hadoop distributed file system. So you can see in this particular picture, we have a name node, we have a backup node, and we have few data nodes. In earlier slide, I was using normal terminology, that is master machine, slave machine, and you can say backup master machine. But now you can say that we have some Hadoop terminology. We have a name node that is ultimately your master machine. We have a backup node which is ultimately your secondary master, or you can say backup, and all the data nodes are nothing but your slave machines. In this picture you can see that name node is controlling all the data nodes, because as you know we are interacting with master machine only, and that is interacting with multiple slave machines. So one more thing you can notice is that these colorful blocks are nothing but the smaller parts of a bigger file. The file was too big that it could not be stored on a single system. That's why what we have done is we have splitted that bigger file into smaller parts, so that those smaller parts can be stored very easily on multiple machines. You can see this. 3 blocks are stored on first machine, the next 3 are stored on next machine. Similarly, all machines are participating in storage. So the complete storage is ultimately distributed among multiple machines. That's why it is known as Hadoop distributed file system. One more thing you can notice is that every data node has a its local hard drive on which it is storing the data. But name node and backup node does not store the data. That's true, because name node and backup node, that you can say master machine and secondary master machine, they are neither storing the data nor they are participating in the processing. So what exactly they are doing? They have a lot of other things to do. They are managing your machines, they are distributing the job, they are coordinating with them. So all the management related activity is taken care by master and backup master. All the data storage distributively and data processing distributively is taken care by all the slave machines. So this is the storage part of Hadoop, known as Hadoop distributed file system. Anyone who is having any doubt on this slide? Okay, I think we can move to the next slide. The next is MapReduce. MapReduce is like your processing part of Hadoop. We were saying that we have two parts of Hadoop. One was distributed storage and another one is the distributed processing. So MapReduce is the technical Hadoop terminology for distributed processing. So MapReduce plays a key role in Hadoop framework. Why it's playing key role? Why the storage was not playing the key role? Because nowadays storage is not a big deal. You can store the large amount of data very easily. Maybe you can purchase some extra hard disk, some portable hard disk, and there are so many cloud storage available. You can store over there. So storage is not a big deal nowadays. But yes, processing the large amount of data on multiple machines distributively is definitely something challenging. That's why MapReduce plays very important role in Hadoop framework. So MapReduce is a programming for writing applications that rapidly process a large amount of data. MapReduce program is nothing but a special type of Java program, but it has a specialty that it can be executed on multiple machines parallelly. Because our data was splitted and stored distributively on multiple machines, to process that distributed data, we need such technology which can be executed parallelly on multiple machines, so that the data which is already stored distributively can be processed distributively on multiple machines. So MapReduce you can say, consists of two words. One is map and another one is reduce. So in order to understand what map is and what reduce is, I will take you back to the school example. Let me remind you that principal has distributed the task of checking 1,000 answer sheet among 10 teachers. That means one teacher is responsible for checking 100 answer sheets only. And one teacher is not bothered about other teachers, because some task is assigned by master to slave. That means from principal to teacher. So every teacher will be doing their independent activity. They will be preparing the result of 100 students independently. But the point is that when your principal will come and principal will say that I have distributed the task among all of you, that's fine. But that does not mean that you 10 teachers will be giving me 10 different results. I don't need that. I still need one consolidated result for my school. So now what can be done? Principal may be choosing one teacher that can you please take the small result from all the teachers and can you please consolidate that result in a single output. That's what I'm looking for. So now let me tell you what is mapper and what is reducer. That independent activity each teacher was doing, checking of 100 answer sheets, that activity is mapper. And your reducer is fetching intermediate output from all the mappers and generate final output data. That means one teacher who was collecting the intermediate result from multiple teachers and consolidating that into a single consolidated result. That consolidation activity is known as reducer. So this whole example was just for your quick reference so that you can quickly get the idea. Otherwise, in Hadoop perspective, you can understand that your master machine distributed some job among multiple slave machines, and multiple slave machines were doing the independent activity that is known as mapper. And later on, one slave machine will be consolidating the intermediate output into a single output that is known as reducer. So this is about what mapper and reducer is. If you want some definition type thing, it's there on the slide. Mapper process input data parallelly on multiple machines to generate intermediate output data. Because what mapper is producing is not the final output. That is intermediate output which needs to be consolidated. Reducer will be fetching intermediate output from all mappers and generating final output data. So this is about the slide. Hadoop services. When we say that Hadoop will be processing the data and all that, that means we need to install Hadoop. And whenever we install any service, any software on our system, few services are running behind every software. So behind Hadoop, what are the services running and what are their purpose? Let's talk about that. The two services are name node and data node. You may be thinking that few slides back I was saying that master machine is known as name node and slave machine is known as data node. But now I am saying that name node is a service. So which one is true? Name node is a service or name node is the name of master machine? Basically name node is a service only, but the service is running on master machine. And that's why master machine is also known as name node. So don't get confused with that. Name node is a service which is running on master machine, and a data node is a service which is running on every slave machine. And these two services, name node and data node, these two services are taking care of storage part of Hadoop. That is your HDFS, Hadoop Distributed File System. Similarly, we have two more services, job tracker and task tracker. Job tracker is running on master machine and task tracker is running on every slave machine. So job tracker and task tracker both are taking care of your processing part, that is your map it is. So if you want to see it graphically, you can see this. We have a central box, that's my master machine. On master machine, master services are running, that is name node and job tracker. We have a secondary name node as well, that is the backup of master machine. And apart from master and backup master, we have 5 slave machines. Data node and task tracker services are running on every slave machine. So you can see that name node along with all the data nodes is taking care of your storage part. And similarly, job tracker along with all the task tracker is taking care of your processing part. So these are different Hadoop services which will be running on your system when you will be installing Hadoop. Okay, moving to the next slide. What is big data? You must have heard two terms. One is Hadoop and another one is big data. Even if you will go on Google, sometime you will find big data training, somewhere you will find Hadoop training and so many things. So are these two things, Hadoop and big data, are they same? No, they are not exactly same. They are related but not exactly same. So we'll be talking about the difference between Hadoop and big data. Before that, let's try to understand what is big data. So big data is story of 3 V's. And those 3 V's are volume, velocity and variety. You have seen the volume of the data, right? In just that 5 seconds, those millions of GB of data was transferred over the internet. So volume of data is very high. And velocity, that terabytes and petabytes of data was generated and transferred just in 5 seconds. So definitely velocity of data is very high. And then variety. We have text data, we have transactional data, you are uploading images on Facebook, you are watching videos, you are doing something different. So we have audio, video, images, text file, transactional data. The data variety is too high. So if I will combine these 3 V's, that is volume, velocity and variety, you can say that the data complexity is very high. And to deal with this complex data, Hadoop is not sufficient. Because Hadoop is a base technology. On top of Hadoop, we need few more technologies that can be HBase, Hive, Pig or Scoop. And there are so many others. These all sub-technologies are dependent upon Hadoop only. Now you can see that Hadoop is base technology, and what big data is? Big data is a combination of Hadoop plus its sub-technology. That means either you can say that you are working on Hadoop, HBase, Hive, Pig, Scoop. Otherwise, you can simply say I am working on big data technologies. So big data is nothing but combination of Hadoop plus its sub-technology. So less or more, Hadoop and big data are same. But yes, big data is something bigger. Terminology and Hadoop is the base technology. So this is about what is big data. Any doubt till now? Okay friends, so there is no doubt. Let's move towards the next slide and show something interesting. Why Hadoop is important for career. The very first point is better salary. If you will compare the billing rate of a Hadoop consultant with other technology, you will find it quite higher than other technologies. Because Hadoop is the red hot topic, the latest emerging technology in the market nowadays. The next is big companies are hiring. It's not like something which came into the market and which may be successful or not. It's not like that. It is something on which bigger companies are working. Starting from Google, Yahoo, Facebook. Facebook is even in partnership with Apache on one of the sub-technology, that is Hive. Similarly, because there are many banks across the globe, they have very large amount of transactional data. There are so many e-commerce websites. There are bigger social networks, even offline data like Big Bazaar or Walmart. Even they are doing some analytics on their purchase history with help of Hadoop. So very big companies are involved in Hadoop. That means there are quite a bright future opportunities globally available. All these things, e-commerce website, social networking, transactional, all these things, this is globally available. That means the opportunity for Hadoop is also globally available. And in case you are starting your career in Hadoop or you are switching your career in Hadoop, that means better job opportunities are waiting for you. So these are few points which are important for your career. Okay. Moving to the next slide, prerequisite to learn Hadoop. We are done with little quick introduction of Hadoop. I think now you have the brief idea what Hadoop is. It's a distributed storage and distributed processing environment in which there is a master machine and there are multiple slave machines, which helps you to store and process your data distributively on multiple machines. Now, if we are planning to go for this training program, then what are the things required? So the first thing required is Linux based operating system. You may be attending today's demo from Windows only, but let me tell you that Hadoop cannot be installed on Windows. Hadoop is basically not made for Windows. It's made for Linux based OS only. That can be macOS, that can be Red Hat, that can be Ubuntu. And why I have highlighted Ubuntu in a different color? Because Ubuntu is an open source, free of cost available. That means in case you have Windows, suppose we will not be deleting your Windows. On top of Windows, we will be installing a virtual box, and inside that virtual box we can install Ubuntu. That means your personal things you can still do on your Windows, and for Hadoop related training and for Hadoop related hands-on practice, you can use your Ubuntu. So whenever we start a new batch, the first 2 days are dedicated for Ubuntu and Hadoop installation on your system. The next is Java 1.6 and or higher version is required. Java is again open source. We can download it and install it within 5-10 minutes. That's one-time activity. The next is the disk space is required to hold a large amount of data. And RAM is also required for processing your data. But I think needless to say, if someone is having PC or laptop, he or she will be definitely having some hard drive and some RAM to process and to store the data. After that, we need a group of computers. We were looking at some picture earlier. Let me go back to that. This one. As per this picture, we need 7 machines. One is master, one is backup master, and 5 are slaves. So for learning purpose, do we really need 7 systems? No, that's not required. Even a single system is sufficient for installing Hadoop. Because logically, your own system can work as a master machine and your own system can work as a slave machine. That means all master services and all slave services will be ultimately running on your system only. So there is no cost associated with software because this is free of cost. There is no cost associated with hardware because whatever PC or whatever laptop you have, that can be used for Hadoop installation. So friends, this is all about prerequisites for learning Hadoop. Any doubts or anyone who wants to add something to this? Okay, so let's move to the next and the last slide for today. That is Hadoop training details. So there are two types of Hadoop training. One is Hadoop developer, which needs prior Java knowledge. The guys who are coming from Java background, those guys can go for Hadoop developer profile. Another and more famous profile is Hadoop admin, which does not need Java knowledge, which is suitable for guys from database, data warehousing, informatica, mainframe, and business intelligence background. So people are coming from different fields, even they are having not experience or they are not knowing the Java. That's fine. They can still jump into this big data world. And the training program which we are offering, which provides Hadoop admin plus Hadoop developer plus HBase, Hive, Pig, Scoop, and a POC, proof of concept. So we'll be starting with Hadoop because that is the base technology. Once you are comfortable on Hadoop, then only we can think of other sub technologies. That is HBase, Hive, Pig, Scoop, and a mini project. And all these things we will be doing from very beginning. I mean, starting from zero level. How to start, how to get the software, how to install Hadoop, how to load the data, how to execute the job, and how to use this sub technology to process your data in more effective way. So these are the technical details of your training. So non-technical details are the training duration is 1 month, that is 5 days a week. Those 5 days are from Monday to Friday morning, that is India timing. That would be Sunday to Thursday evening, that is US timing. So friends, with this slide, we are done with the introduction to